Welcome to The Explainer. Today, we're tearing down a massive paradigm shift happening right under our noses. How the top 1% of engineering teams are fundamentally redesigning their entire workflow around AI. And listen, this isn't about just using AI as a glorified spell checker for your code. We're talking about treating AI as the absolute primary builder of your product. Check out this wild case study from Creo AI. This is a tiny team of just 10 engineers who managed to collapse a standard 6-week product cycle into a mere 7 hours. How? They let AI write 99% of their production code. I mean, they shipped a feature at 10 a.m., A/B tested it, completely killed it based on bad data by 3 p.m., and shipped a totally revised version by 5 p.m. It's just mind-blowing. To see how they pulled off this impossible speed, we're going to look at 5 structural changes: the AI-first illusion, breaking bottlenecks, the unified monorepo, deterministic pipelines, and finally, the new engineering organization. All right, Section 1, the AI-first illusion, diving into vibe coding versus actual production systems. There is a massive difference between just having an AI-assisted workflow and actually being AI-first. Right now, a ton of developers are doing what we call vibe coding. Tweaking a prompt in your IDE over and over until a prototype magically spins up. Sure, you might get a 10 or 20% efficiency bump, but honestly, bolting AI onto an old legacy process is not an AI-first strategy. Vibe coding gets you quick prototypes. It absolutely does not give you production-grade reliability.
So how do we get past the massive risks of vibe coding? You have to build a deterministic system. You essentially restructure your entire architecture so the AI does the heavy lifting of the actual building, and the human engineers simply provide the direction and the judgment. In this new paradigm, the rigid system you build to host that AI is your golden asset. The prompts you use, those are entirely disposable.
Moving right along to Section 2, breaking development bottlenecks. Because, as it turns out, speeding up just the coding phase causes some huge headaches. Here's the trap. Imagine your AI agent blasts out a massive feature in like 2 hours. That's the fat middle section of your pipeline, right? But if your product managers are still taking weeks to write out traditional specs, and QA is spending days manually clicking around testing corner cases, your entire pipeline just chokes. The sheer speed of the AI implementation literally breaks the rest of your traditional workflow. The takeaway here is absolutely crucial. You cannot have a single manual node left in your process. 0. If one step is manual, the whole system grinds to a halt. Your validation, your planning, even your QA testing platforms, they all need to be built by AI so that every single piece moves at the exact same lightning speed as the coding agent. Which brings us to Section 3, the unified monorepo and creating legibility for your agents. Think about the old way of doing things. You had fragmented, multi-repo code bases. And sure, human engineers can context switch and jump around between them. But to an AI agent, that structure is completely opaque. It's practically invisible. The fix here is the monorepo. By pulling all your code into a single, centralized repository, the whole system suddenly becomes beautifully legible. Now the AI can actually inspect, understand, and modify your entire architecture in one go. This brings us to a fascinating new concept top teams are using called harness engineering. I absolutely love this framing. It means we stop looking at AI as just a human replacement, and we start treating it like a massively powerful engine. And what does a massive engine need? It needs a perfectly rigid track to run on. Harness engineering is simply the discipline of building that exact track, giving the agent maximum leverage to do its things safely. Naturally, this leads right into Section 4, deterministic pipelines, or keeping that AI engine firmly on the rails. Okay, to make this actually work, every single pull request has to run through a very exact 6-phase deterministic pipeline. Verify, build, test, deploy, test again, and release. The absolute key detail here: 0 manual overrides, no exceptions whatsoever. This extreme strictness is exactly what lets the agents perfectly predict outcomes and operate safely without breaking things. And check this out. When a pull request gets submitted, it automatically triggers this wild 3-dimensional review pass by Claude Opus. It simultaneously scans for code quality and logic errors, hunts down security risks, and checks all dependencies for supply chain conflicts. The AI makes the PR, and the AI reviews the PR. The human operator, you're just there to check for final business risk. That's it. It gets even crazier when you look at production. Every single morning, 9 a.m. UTC, an automated sequence kicks into gear. It spots errors in CloudWatch, analyzes the patterns, clusters them by severity, auto-generates tickets in Linear with suggested fixes, and then just assigns an agent to go write the code. It is literally automating away your technical debt while you sip your morning coffee. How cool is that? By pairing that automated tech debt loop with instant feature gates, the CREO team saw insane results. They went from 0 releases in a standard 2-week sprint to averaging 3 to 8 production deployments every single day. If a feature flops, they kill it that afternoon. Tighter feedback loops just inherently build better products. All right, Section 5, the new engineering organization, architects versus operators. So what happens to the humans when the system builds and heals itself? Well, the traditional corporate hierarchy completely collapses into just 2 core roles. First, you've got the architect, usually just 1 or 2 folks who design the standard operating procedures and basically act as the chief critics of the AI. Then you have the operators. That's everyone else. Their job is to investigate bugs, validate what the AI diagnoses, and verify the final UI. Here is a really surprising nugget from the source material. Adaptability actually matters way more than accumulated skill now. They found that junior engineers adapted to this new world so much faster. Why? Because they felt super empowered by the tools, and they didn't have 20 years of rigid, manual coding habits to unlearn. On the flip side, senior engineers actually struggled the most. It's a tough pill to swallow, realizing that months of your elite manual work can now be cranked up by an AI in about an hour. Plus, traditional middle management basically evaporates. The time spent just managing people plummeted from 60% down to under 10%. The CTO literally went back to coding and building full-time. And because the strict automated system handles the technical trade-offs based on the architect's rules, all those endless alignment meetings and team arguments, gone. They were replaced by casual chats and, honestly, just much better relationships across the team. As we wrap this explainer up, I really want you to take this one concept home. Fast AI without fast validation is just fast-moving technical debt. Moving forward, your competitive edge isn't the size of your proprietary codebase anymore. Your true advantage is the speed of your iteration loop and the absolute strength of your validation harness. Which leaves us with a final, pretty provocative thought from the source material. Think about this. If one architect, armed with a proper deterministic system and intelligent agents, can literally do the work of a 100-person team, a lot of companies might never need a second employee. So the question is, are you ready to become the single architect of your own automated empire? Or are you going to be left behind, clinging to your old code editor? Thanks for joining me on The Explainer.